actually sit down with them and find out how they really make decisions. The interesting thing is you have to do that in a couple of different ways, both in Australia and anywhere in the world. If you're in a public forum like this, and I'd say, how do you make a decision, particularly in front of farmers, they'll give you one answer, but if you go into their home and you ask them, you get a very different answer. So in public, they want to be seen as good businessmen and good leaders. They give you an answer that reflects that. In their home, they're worried about their families and social things and how people are going to cope. And they're not the same answers. So you have to ask people in lots of different ways and lots of different settings to actually get information if you're trying to get information out of people about how people. So we talked about land use before. Another one of those is urban. So on this particular map, that grey area there is the city of Tokyo, which is the biggest continuous urban area in the world. So you can see that it's a densely urban area. From someone in Australia where when I grew up as a kid, my nearest neighbour lived 5 kilometres away. Okay? I never had to worry about space. We had an outdoor toilet, you just let the door open because no one was ever going to come and disturb you, except maybe a snake. That's a In Tokyo, when my husband and I were there on our honeymoon, we couldn't understand why you weren't even allowed to eat or drink on the sidewalk. And it was a 45-degree day and it was really hot. And a very elderly Japanese gentleman had bought a drink and he stood to the side and he opened it and his wife turned around and yelled at him. And I'm thinking, that's a bit harsh. The guy looks like he's about to die. It's so hot. And it was because when you hold hands, which is another no-no in Japan, or when you open a drink, it's because you're disturbing the flow of the people around you. There's so many people who have to get to places that if you're creating a blockage, if you think about a river, you're really disturbing all that flow. So they have social rules that make their life easier. And those kind of things can be explored in models as well. There's quite a lot of theory that comes behind how urban areas develop. So the original idea came from the way that European cities basically started as a fortress and grew out. But in reality, that's not what urban cities are like. They're much more like the Hoyt's wedges, where you actually get sort of wedges of a high income or wedges of a poor income. So Tasmania is a pretty good example. You live in Hobart, you live to the south of Hobart, you're probably on an average to higher than average income. If you're in the north of Hobart, you're probably in a very low income. The two, there is a little bit of mixing between them to go to shops or stuff like that, but really they're almost two separate worlds. Even politically, people in the north tend to have more stickers that they hate the idea of a Green Party, whilst the people in the south have stickers on their cars that they vote for the Green Party. Okay, it's a very bipolar area. But that's actually more and more common in cities in the Western world. But again, not even that explains what happens in the developing world. So this is actually an example of an open-air market. But there's a beautiful YouTube of this, but I wasn't sure that it would actually run. It's actually on a railway track. So when the train comes, you see all the shutters go in, people get their produce off, the train goes through, all the shutters come back out, they put their produce back out and keep going. So this is really high density housing. Malaysia. So this is why they're starting to have to invent new models for how places in the developing world actually work. Because in places like India and other places like that, you'll have really, really rich suburbs right next to the suburbs of the people who basically the higher help that come in to help them. So they grow in a very different manner to what we've seen in other places around the world. You've also got to drop geography in it. You've always got the idea of general patterns, but if you've got a river that sort of runs in one direction, that can really change how those patterns develop. There are some large agent-based models though, and this is pretty much how all the big countries, all the big cities in the world are now sort of planned. They run this program like Urban Sim, where they simulate how people, how do they literally have a house-by-house model of the city, and all the different people in it, where those people work, where do they live, their access to infrastructure, how the different zoning plans are, and they play it out so that they can understand zoning, but also so that they can marry it with the sort of live weather forecast that Raghu was talking about, so they can do that emergency planning of what's going to happen when that flood maybe breaks or you have a big storm. So this is now a very aged example, but you can see that these colours are slowly changing. This was a run for a city from the mid-1980s to the mid-1990s, and the number of jobs, for instance, per area. So they could even understand where some of the unemployment would land, where the jobs would be, where there'd have to be pathways for transport. And you can map pretty much anything. So this is different scenarios of housing on one side, different scenarios for employment on the other. And you can see, depending on the scenarios that they had around where they put their infrastructure, where they put their green space, you could get different shapes to the density of jobs and the density of housing. The other one that they do a lot is a one-to-one model. So in America, for instance, and in Australia, there's literally a one-to-one model of the entire population so that they can understand epidemic spread. So if we take the old epidemic models, the differential equation ones, they didn't work, they didn't always predict well what actually happened in an epidemic. So if we think about when swine flu came to Australia, every single city was supposed to end up in this particular pattern, and that's what they were going to make all their vaccine deliveries based on. Then they got the agent-based model and said Sydney will do something like that classical model, but in Melbourne it will be completely different. The epidemic will explode in 2 weeks. Most of the population will get either at least a mild dose. And they couldn't understand why it was going to be so different, unless you understood the fact that in Melbourne, that there's a really good public transport and they also all love football. So every weekend, the whole population of central Melbourne walks to the football and mixes with each other. So there was an enormous exposure that you didn't get in the classical model, and you didn't get in Sydney, where they tend to live in more segregated suburbs that have different structures and they don't mix it. So that's what they're using those kind of models for. And these kind of models have things happening at different scales, from neighbourhood scales to small suburban satellite scales up to the whole city scale. They're starting to support these zones that you can see are very intermingled and quite complicated because they're trying to meet so many objectives about how things go. And part of that reflects the fact that they also have to include this lobbying factor. So if you think about what people like, different people have different ideas about what they want to have close to them. So fairly affluent people like to have space and potential, at least in Australia, like to have space and green space and things like that. So this was just the way that the council versus sort of the environment or agency versus some of the newly affluent people would have liked to see areas in a town managed. So all you just got to take from that is that the curves were different, so not everyone's going to that big area. And stepping up some scales, you get into the huge kind of economic models that she gave you a little bit of a taster for. But basically these sort of can cover investment and taxes and how the government works. And then when you spin them out, these general equilibrium models out to a national scale, they follow, for instance in Australia, they follow 90 regions and 180 different kinds of sector. So electricity and fishing and forestry and agriculture, blah, blah, blah. The whole list in each sector, they're basically trying to follow the flow of money, well not necessarily money, but the flow of materials and stuff through that system so they can see where demands will be, they'll see where emissions are. Now the place that falls down is that they have to make some simplifying assumptions by saying the population will always look the same, or the emissions and demand from overseas will always look the same. And the step they're taking now as they move into the new integrated models in Australia is they're actually not. They're talking to other models that do the dynamic change, so that you've got people in Sydney have a very different lifestyle and a very different emissions compared to people in the middle of the outback of Australia, so that that's actually being reflected as is changed through time. That's starting to happen on the international level scale too, in the truly integrated assessment models. So for instance, in some of the really big models that Australia uses the global model to condition its national model when it's making its decisions. These are the kinds of sectors, the other kinds of regions. So Australia's consciously thinking about what the rest of the world's going to do when it's trying to think about what its economy is going to look like and what its emissions are going to look like. Then you get into global trade models where you start to get more to the game theory end of how different countries are going to react. So a bit of a mix of game theory and agent-based theories, how they're represented. And the area that's shot forward in huge leaps and bounds over the last 10 years has actually been the agent-based modelling of conflict. So what they did when they first went into Afghanistan and Iraq was they employed a whole bunch of modelers to sit down there and figure out how to model insurgents. So they could figure out what were going to be dangerous routes for IEDs, how they were going to deal with the evolution. So if we think about parts of the reasons of why some of the damage was as high as it was because the insurgents were learning very, very quickly. So, you know, they had old rifles. They didn't work. The Hummers are too big. But the bottom of the Hummer isn't, so we invented IED. Okay, they go and put metal plates in there. So we stick the IED to the side of the road posts, so it blows out through the side of the door. They start to having to make a big metal box. We start to undermine the city streets, so they go into the holes. There was an evolutionary game happening between the military and the insurgents. So they had to think about how to break that game. So this is some of the pressures or some of the parts in how they think an insurgent makes their decisions. So where are the incentives to break that? You know, if you're a Afghani farmer who after the poppy season has the option to starve to death or get paid $20 by the Taliban to sit there and watch what the Americans are doing, then you've got to think about where you can target your nudge factors in that to try and break that behaviour, give them incentives to do something else. The other part they've looked at is how that can actually go up through tribes into actual conflict between the different tribal groups, for instance. So that whole area is just getting bigger all the time. Now, one of the questions we often get when we get into these big integrated models is, what if we'd done this in the past and we actually tried to manage the future the same way we're talking about it now? So if we'd gone back to the 1970s and tried to have an integrated assessment model, could we have said the way the world works and made better decisions? Because that's what we're claiming of the current groups, right? Well, part of that is based on how you respond to those models. So I don't know how many of you have heard about limits to growth in the Club of Rome. Basically, back in the 70s, there were a group who sat down who tried to do that, to model the world, to give people some ideas about what would be the issues. And fundamentally, they were vilified. The pure economists, not the kind of ecological economists that Rashid is, but the pure economists said, it's all crap. Those feedbacks don't exist. It's a bunch of crap. We will find technology that fixes it. Okay? But it's now been 30 years. So the group got back together and they looked at how the world had actually gone versus their predictions. So they didn't just have one prediction. They'd done the scenarios, and the solid purple in each one of these is what the world's actually done. And they got it right, pretty much. For something that was a pretty simple model, they nailed it in their gross terms. So there's some parts that the next few years will be the teller about whether we keep going or whether that happens to diverge. But if you think of one of the biggest arguments that the economists made was that pollution was so bad that people were already doing things to clean up rivers and to try and remediate. So obviously they were wrong. But if you think of carbon dioxide as a pollutant, they nailed it. They got climate change before it was really on any of the government radars. And they said we had about 2050 to get it right before the global community basically fell off the cliff. And that was why the major economists, or at least part of the economy, was so radically a fight back, because they didn't think that was true. So that's one of the tensions we're still fighting today, because if you go to an open economic forum, or you go to people who have heard something about the limits to growth, like my boss, it was like, well, the limits to growth was completely, everyone showed that was wrong. And in fact, they really didn't show that was wrong. So part of it is about how you educate and communicate that stuff. Okay, so if you just think about the integrated assessment models for now, it's been that sort of email backwards and forwards between the physical guys and the economists, like I spoke about the first day. We're going for much more integrated ones now. We're trying to pull those different sector representations together. And if something's left out, that's fine. You have to simplify your models, but you need to think about whether you should have just had an impact factor or something. Just think about why you're leaving things out. We're not the only people trying to do it. So one of the most popular games in a recreational sense that's been played over the last 20 years is a thing called SimCity. SimCity now has climate change, urban disasters, overpopulation, depletion of resources. And the latest version that comes out, I think, in 2 months' time, actually has game theory behind it. If you're playing online, if Stuart decides to pollute, his city degrades, but it can also wave across and start to affect me, creating tension, so the ability to cooperate. There's actually a whole industry now growing up in the gaming world around games based on climate change. So there's a thing called Fate of the World where you get to play a world leader. And you're all online trying to be world leaders to see if you can find a solution to climate change that doesn't economically bankrupt the city.